question addresses a scenario involving a 400 amp main lug only, 208/120 volt, 2-section PAL fed from a 400 amp breaker. These two sections are separated with a distance of approximately 5 feet 6 inches between them. The question is whether it is permissible to feed through the second section without overcurrent protection, assuming the total distance is less than 10 feet. The answer is no. It is not allowed to feed through the second section of the panel without overcurrent protection. Article 240.21 of the National Electrical Code, commonly referred to as the NEC, stipulates that overcurrent protection must be provided for each ungrounded conductor of every branch, circuit and feeder. In this specific scenario, the conductors extending from the 400 amp breaker to the second section of the panel are classified as a feeder. Consequently, these conductors must be safeguarded by an overcurrent device that is rated for no more than the ampacity of the conductors themselves. Ampacity, in simple terms, refers to the current carrying capacity of a conductor. It is the maximum amount of electrical current, measured in amps, that a conductor can continuously carry without exceeding its temperature rating. Several factors influence the ampacity of a conductor, including the conductor's size, material, insulation type, and the ambient temperature in which it is installed. The NEC provides tables such as Table 310.16 and others that specify the allowable ampacities for various conductors under different conditions. These tables are essential for ensuring that conductors are not overloaded, which can lead to overheating, insulation damage, and potentially electrical fires. Selecting the appropriate conductor size and overcurrent protection based on ampacity is a critical aspect of electrical safety. The NEC does permit a maximum of 10 feet of unprotected conductors between the overcurrent device and the first point of utilization under specific conditions. These conditions are outlined in NEC Article 240.21, specifically addressing tap rules. A tap conductor is a conductor that receives its supply from a feeder conductor. The tap rules allow for short runs of unprotected conductors under very specific circumstances, primarily to facilitate connections to overcurrent devices or equipment. There are several tap rules, each with its own specific requirements concerning the length of the tap conductor, its ampacity relative to the feeder conductors, and the type of occupancy. One such rule, often referred to as the 10-foot tap rule, allows for unprotected conductors up to 10 feet long, provided certain conditions are met. Firstly, the tap conductor's ampacity must be not less than the calculated load it serves. Secondly, the tap conductor must not exceed 10 feet in length and must be enclosed in a raceway from the point of tap to the overcurrent device. Thirdly, the tap conductor must not extend beyond the equipment it supplies. However, in the situation described, the distance between the 400 amp breaker and the second section of the panel exceeds 10 feet. Therefore, the exception allowing for up to 10 feet of unprotected conductors does not apply. To reiterate, because the distance exceeds the allowable limit, overcurrent protection is required at the point where the feeder conductors supply the second panel section. This overcurrent protection must be sized appropriately, considering the ampacity of the feeder conductors and the load served by the second panel section. The NEC is the cornerstone of electrical safety in the United States. It is a comprehensive set of standards and guidelines designed to protect people and property from electrical hazards. The NEC is developed and updated every 3 years by the National Fire Protection Association, commonly known as the NFPA. It covers virtually every aspect of electrical installations, from wiring methods and overcurrent protection to grounding and bonding requirements. Adherence to the NEC is essential for ensuring that electrical systems are installed and maintained safely. Electrical inspectors use the NEC as a benchmark when evaluating electrical installations. Compliance with the NEC is often mandated by law, and failure to comply can result in fines, project delays, and even legal liability. It is important to consult the latest edition of the NEC and to seek guidance from qualified electrical professionals when designing, installing, or modifying electrical systems. The NEC addresses various aspects of overcurrent protection, including the types of overcurrent devices, their ratings, and their installation requirements. Overcurrent devices are designed to protect electrical circuits and equipment from excessive current flow, which can cause overheating, insulation damage, and electrical fires. There are two primary types of overcurrent devices: fuses and circuit breakers. Fuses are one-time devices that contain a fusible link that melts and opens the circuit when the current exceeds a predetermined level. Once a fuse has blown, it must be replaced. Circuit breakers, on the other hand, are resettable devices that use a mechanical mechanism to trip and interrupt the circuit when an overcurrent condition occurs. Circuit breakers can be reset manually, allowing the circuit to be restored after the overcurrent condition has been resolved. Both fuses and circuit breakers are available in a variety of sizes and ratings to accommodate different circuit requirements. The selection of the appropriate overcurrent device depends on several factors, including the circuit's voltage, current rating, and the type of equipment being protected. Overcurrent devices must be installed in readily accessible locations and must be protected from physical damage. The NEC also specifies requirements for the coordination of overcurrent devices to ensure that the device closest to the fault opens first, minimizing the extent of the outage. Grounding and bonding are critical safety measures designed to minimize the risk of electrical shock and to provide a path for fault current to flow back to the source, allowing overcurrent devices to operate and clear the fault. Grounding refers to the connection of an electrical system to the earth, providing a low impedance path for fault current. Bonding refers to the connection of all metal parts of an electrical system to create an electrically conductive path. Together, grounding and bonding help to ensure that metal parts do not become energized during a fault, reducing the risk of electrical shock. The NEC specifies detailed requirements for grounding and bonding, including the size and type of grounding and bonding conductors, and the methods of connecting them. Proper grounding and bonding are essential for the safe operation of electrical systems. In the context of the described scenario, several options exist to address the requirement for overcurrent protection at the second panel section. Firstly, install a sub-V breaker in the first panel section. This involves installing a circuit breaker in the first panel section that is rated to protect the conductors feeding the second panel section. The ampacity of this breaker must be selected based on the ampacity of the conductors and the load served by the second panel section. This approach provides overcurrent protection at the source of the feeder, ensuring compliance with the NEC requirements. Secondly, utilize a junction box with a fuse disconnect. Install a junction box near the second panel section and incorporate a fuse disconnect switch. This arrangement provides a means of disconnecting the power to the second panel section for maintenance or emergencies, while also providing overcurrent protection via the fuses. The fuses must be sized appropriately to protect the conductors and the load. Thirdly, replace the existing panel with a single larger panel. This involves replacing the two separate panel sections with a single panel that has sufficient capacity to accommodate all of the required circuits. This approach eliminates the need for a feeder between two separate panels, simplifying the installation and ensuring compliance with overcurrent protection requirements. In all cases, it is crucial to consult with a qualified electrical professional to determine the most appropriate solution for the specific application and to ensure compliance with all applicable codes and standards. Furthermore, any electrical work must be performed by licensed electricians who are familiar with the NEC and local electrical codes. Electrical safety is paramount, and any electrical work should be approached with caution and diligence. It is important to energize circuits before working on them and to use appropriate personal protective equipment, such as insulated gloves and safety glasses. Regular inspection and maintenance of electrical systems are also essential for ensuring their continued safe operation. By adhering to the NEC and following safe work practices, the risk of electrical hazards can be significantly reduced. When evaluating the ampacity of conductors, it is important to consider dirting factors. Dirting refers to the reduction in ampacity that is required under certain conditions, such as when multiple conductors are bundled together or when conductors are exposed to high ambient temperatures. The NEC provides tables and guidelines for dirting conductors under various conditions. Ignoring dirting factors can lead to conductor overheating and insulation damage. Therefore, it is essential to carefully consider directing factors when determining the appropriate conductor size and overcurrent protection for an electrical circuit. In addition to overcurrent protection, ground fault circuit interrupters, commonly known as GFCIs, are another important safety device. GFCIs are designed to protect people from electrical shock by detecting ground faults, which occur when current leaks from a circuit to ground. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing electric shock. The NEC requires GFCIs in certain locations such as bathrooms, kitchens, and outdoor areas where the risk of electric shock is higher. GFCIs are an essential safety device for protecting people from electrical hazards. Arc fault circuit interrupters, commonly known as FCIs, are designed to protect against electrical fires caused by arc faults. Arc faults are unintentional electrical discharges that can occur when insulation is damaged or when connections are loose. FCIs detect arc faults and interrupt the circuit, preventing the arc fault from igniting nearby combustible materials. The NEC requires FCIs in certain locations, such as bedrooms, to provide enhanced protection against electrical fires. FCIs are an important safety device for preventing electrical fires. Surge protective devices, commonly known as SPD, are designed to protect electrical equipment from voltage surges, which are transient increases in voltage that can damage sensitive electronic components. SPD diverts surge current away from the equipment, protecting it from damage. The NEC recommends SPD in certain applications, such as for sensitive electronic equipment, to protect against voltage surges. SPD are an important safety device for protecting electrical equipment. Proper labeling of electrical panels and circuits is essential for safety and troubleshooting. Electrical panels should be clearly labeled to indicate the circuits they serve. Circuit breakers and fuses should be labeled to identify the equipment or areas they control. Proper labeling helps to prevent accidental disconnection of critical circuits and facilitates troubleshooting. The NEC specifies requirements for labeling electrical panels and circuits. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safe operation. Electrical panels should be inspected periodically for signs of corrosion, overheating, or damage. Circuit breakers and fuses should be tested to ensure they are functioning properly. Wiring and connections should be checked for tightness and integrity. Regular inspection and maintenance can help to identify and correct potential problems before they lead to more serious issues. The NEC provides guidelines for inspection and maintenance of electrical systems. When working on electrical systems, it is essential to follow safe work practices. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Use properly insulated tools. Never work on electrical systems in wet or damp conditions. Follow lockout-tagout procedures to prevent accidental re-energization of circuits. By following safe work practices, the risk of electrical hazards can be significantly reduced. The information provided is intended for general guidance only and should not be considered a substitute for professional electrical advice. Electrical codes and standards are complex and subject to change. It is essential to consult with a qualified electrical professional to ensure that electrical systems are designed, installed, and maintained in accordance with all applicable codes and standards. Electrical safety is paramount, and any electrical work should be approached with caution and diligence. Remember, the principles of overcurrent protection are critical for electrical safety. Proper selection and installation of overcurrent devices, in accordance with the NEC, safeguards both people and property from the dangers of electrical hazards. Understanding ampacity, tap rules, and directing factors further enhances the ability to design and maintain safe and reliable electrical systems. In summary, the described scenario necessitates overcurrent protection at the second panel section due to the distance exceeding 10 feet, as mandated by NEC Article 240.21. The options presented, including installing a subfeed breaker, utilizing a junction box with a fuse disconnect, or replacing the panels with a single larger panel, provide solutions that ensure compliance with the NEC and promote electrical safety. Always consult with qualified professionals to determine the best approach for specific applications and to ensure adherence to all relevant codes and standards.